I mentioned before that this capital N right here, that's for we're saying that A, B, and C are elements of the set of natural numbers. Okay, there's another variable or another capital letter. This is what's referred to. This is U, obviously, and U is what we call the universal set. This defines all of the elements that are possible to be working with. I'm also teaching pre-calculus, and in pre-calculus I told the students, hey, all we're going to be working with this semester is real numbers. The U defines that meta set, that largest set. It sets the universe, it sets our boundaries, and then all the other sets that are a part of the universal have to contain only elements that are in the universal set. And so this is, this basically, if you want to think about it this way, this sets the context under which we are working. It's important that I talk about subsets and what it means for sets to be equal. So let's move right into that. Let's suppose that the universal set is the elements 1, 2, 3, bam, 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 all the way up to 9 and 10. So we're looking at just the counting numbers from 1 to 10, and let's say that A is 1, 2, 3, 5, 8. Some of you might recognize what that one is. And B, let's say B is just 2 and 8. Okay? Now obviously A, well, 1, 2, 3, 5, 8, A is, if you think about it, each one of the elements in A are a part of this universal set. So since A is contained entirely within U, then what we say is A is a subset of U. Okay? A is a subset of U. But we could also say that A is a proper subset of U. We would say that the cardinality of A is less than or equal to U. We would say the cardinality of A is also less than U. Okay? Notice I wanted to show this. We say subset when we talk about a set being a subset of the universal set. We're saying that it can be smaller in quantity of elements or equal to the universal set. If we say that something is a proper subset, this is subset, this is proper subset, the only difference is the line underneath. Just like the only difference here is the line underneath. This is A is a proper subset of U, and so in this case, since A is a proper subset of U, then the number of elements in A must be strictly less than U. So right there's the difference. If A is a subset of U, then A could actually be the same size and equal in quantity as U. But if A is a proper subset of U, then the number of elements in A must be less than the number of elements in U. Now in this case, clearly, A is a subset, but it's also a proper subset because the number of elements in A, the cardinality of A, is less than U. Now, it's also the case that B is going to be a subset of U. B is going to also be a proper subset of U, but I think you can see already that B is a subset of A. Okay? Before we start talking about set equality, let me ask you one thing. We'll actually come back around to this, but since we're talking about subsets, I just wanted to say one thing. How many subsets This is another way of saying the number of elements in U, or the cardinality. There's just different notation. How many subsets are there when the number of elements in U is equal to 4? When the universal set just has 4. This one over here has 10, but now we're looking at a different one. I don't want to start with a big problem like this. Let's start with something simpler. How many subsets are there when the number of elements in U is equal to 4? Well, if you look over here where we're talking about subsets, now we're talking about subsets. We're saying that a subset can be the same size or have the same elements in it as the universal set. So if we say that our universal set is, let's go with A, B, C, D. Let's think about now the answer to this question. How many subsets are there when the number of elements is 4? So there's our example. Well, here is a subset. This is one of the subsets. And then you can also create other subsets. So let's do this in some kind of an order. You can also create other subsets by, let's say, starting by removing one of these. So if we remove A, that's just going to leave B, C, D. If we remove B, that's going to leave A, C, D. And if we remove C, that's going to leave A, B, D. And if we remove D, that's going to leave A, B, C. Okay? So there's one subset of size 4. There's 4 subsets of size 3. How many subsets would there be of size 2? Well, let's do it this way. Let's go with A, B, A, C, A, D, and then move over to B, B, C, B, D, whoops, and then C, D. Okay, so 1, 2, 3, 4, 5, 6. 6 elements of size 2, and then how many? Sorry, 6 subsets of size 2, and then how many subsets of size 1? Well, you're going to have 4. A, B, C, and D. Okay, A, whoops, B, C, and D. Is that it? Well, let's think about this. 1, 4, 6, 4. It's not quite. Notice there's some symmetry here. You have 3 with A left out, or you have 3 with B left out, 3 with C left out, or 3 with D left out. You can create AB or CD. You can create AC or BD. You can create AD or BC. See the symmetry there? Yeah, I wonder if you're thinking about something that we've talked about before. 1, 4, 6, and there's 4 of those. 1, 4, 6, 4. Yeah, to complete the symmetry, we're going to have this. Folks, this is one of the rows of Pascal's triangle. We'll come back to that later. But let me tell you something else. There's one other subset of this set, A, B, C, D. And this goes back to what I was saying at the beginning. I want you to think of set A, or think of a set as a cardboard box. When you remove the final element in the box, does the box disappear? Poof, no cardboard box. No, it still stays there. You still have the box. If we start with a set of 4 elements and we remove every single element in that set, what are we left with? We're left with an empty set. We're left with an empty box. You can do it, the brackets just back to back, or you do it with that. Okay? Either one of these, not both of them together, but either the brackets with nothing in between, or the 0 with the line through it. That's the null set. So the empty set is one of the subsets of every set. Now the question was, how many subsets are there when the number of elements in U is equal to 4? Well, we see this 1, 4, 6, 4, 1, and you add all that up together, and you get 16. Does that seem like maybe it's a particular number that we might see a pattern with something else? Well, hold on. Let me go to the next page. Let's think about this. Let's do a simpler problem. Let's say the number of elements in our set is, let's go with number of elements in our set A is just A, B, C. 3. Well, if I just changed horses in the middle of the stream, I started out by saying the number of elements is 3, but then I went ahead and wrote the whole thing out. So, oh well. So, the number of elements in 3 is 3. The elements themselves are A, B, and C. So the number of subsets is going to be, well, you can have the whole thing. My brackets are not good this time. Or you could remove one element. And we could remove C, we could remove B, we could remove A. So size 3, size 2, size 1 would just be A, B, C, size, see, 3, 2, 1, oh, size empty set, size 0. And notice that's 1, 3, 3, 1. Recognize that? That's another row of Pascal's triangle. And 1, 2, 3, 4, 5, 6, 7, and the original set makes 8. The number of subsets is equal to 8. Hey, that's half as many as we saw before. Let me just do something here real quick. Remember that? Think about that for a little bit, but let me wrap this up. So, if there are 8 subsets, how many proper subsets? Remember, this is not included as a proper subset, because when we talk about subsets, remember the symbol for that? And we talk about proper subsets, that's just like this. These are the number of subsets. Number of proper subsets doesn't include that. So the number of proper subsets is going to be 1 less than this. The number of proper subsets in this case is not going to be 16, it's going to be 15. Okay, but I want you to think about this. There's 4 elements in here, and we ended up with 16. There's 3 elements in here, and we ended up with 8. What is 2 cubed? It's 8. When there were 4 elements, ended up with 16. So the number of subsets is going to be 2 to the n. The number of proper subsets, where n is the number of elements in that set. Okay? I think that's enough for this video. I'll pick up with another topic on the next video.